Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The first ionization constant, Ka1, of a dicarboxylic acid depends on the distance between the two carboxylic acid groups. When the two Ka groups are closer together, the inductive field effect of one group on the other is stronger, making the first proton easier to remove, higher Ka1, lower pKa1. As the chain length increases and the two Ka groups move farther apart, the stabilizing inductive effect decreases, Ka1 decreases, and pKa1 increases. Reasoning. Oxalic acid, ethanidioic acid, two carbons. The two Ka groups are directly bonded to each other. The strong electron withdrawing inductive effect of one Ka on the other makes the first ionization very easy. Ka1 is very large, so pK1 is the smallest. Malonic acid, propanidioic acid, 3 carbons 1 CH2 separates the two Ka groups. The inductive effect is weaker than in oxalic acid. Ka1 is intermediate, so pK2 is intermediate. Heptanidioic acid, pymalic acid, 7 carbons 5 CH2 groups separate the two Ka groups. The two carboxyl groups are far apart, the inductive effect of one on the other is negligible. Ka1 is smallest, most similar to a monocarboxylic acid, so pK3 is the largest. Thus, pK1 pK2 pK3, which is option B. Why other options fail? A. pK1 pK2 pK3, this is the reverse of the correct trend. C. pK3 pK2 is equal to pK1, malonic and oxalic acids do not have equal pKa1 values, oxalic acid is significantly stronger. D. pK3 pK1 pK2, this incorrectly places malonic acid as having the smallest pKa1, which is wrong. Therefore, the correct answer is B. Therefore, the correct answer is option B.